Hi, let's look at another example involving Newton's third law of motion. So, while on a waxed floor, friction-free floor, James, who has a mass of 60.0 kilograms, throws a rope from his backpack to his buddy Jeremy, mass of 80 kilograms, and asks Jeremy to pull him across the waxed floor. Jeremy pulls on the rope while James holds on and doesn't make any effort to pull. James begins accelerating towards Jeremy at 2.08 meters per second per second. So let me draw a quick picture of this. So we have one person who, let's just say the rope is attached to, and then the other person is pulling the rope. So I'll try to indicate that here. I'll make my rope a different color. Okay. So this is our picture. And let's look at the questions and start to figure out what's going on. Maybe I'll label real quick what their masses are just to make it really clear. So James is the one who is not making any effort, and he has a mass of 60 kilograms. So I think this will be easier if I go ahead and label these two. Saves me from having to think about this later on. So that's why I always recommend drawing a picture and then labeling it as much as possible. I can also label the acceleration of James. We know he accelerates at 2.08 meters per second per second. So let's start answering this first question if we can. It says, what is the force of the rope on James? So this is James right here. How much force is he being pulled with? Well, at first it might seem like an impossible thing to know, unless you remember that there's a connection between acceleration and mass and force. And that's Newton's second law of motion, which is the net force is equal to the mass times acceleration, F equals ma. In this case, it said there's no friction involved, so the net force is simply just going to be this tension force here. So we're just going to multiply the mass times acceleration together. Excuse me. So the mass is 60 kilograms, and the acceleration is 2.08 meters per second squared. And so the calculator tells us 60 times 2.08. This acceleration is 124.8. Looks like we need to have 3 sig figs because we have 3 here and 3 here. So we're going to round this to 125. So the amount of force being applied by the rope is 125 newtons. So question 2 says, what is the force of the rope on Jeremy? So if we know that there's a force that James is being pulled with towards Jeremy of 125 newtons, that means that for every force, there's an equal and opposite force. So Jeremy is being pulled towards James at 125 newtons as well. There's nothing to calculate here. We know that every force results in an equal and opposite force. And so the answer is 125 newtons, just the other direction. Question 3 says, what is the magnitude of Jeremy's acceleration? So again, we're going to use that connection between acceleration and force and mass, F equals ma. But if you remember, you can rearrange this equation to solve for acceleration. So the acceleration is equal to the net force divided by the mass. So in this case, the net force is 125 newtons on Jeremy this time. And Jeremy's mass is 80 kilograms. So he's not going to accelerate as much because he's more massive. Let's calculate how much acceleration he'll have. So 125 divided by 80. He has an acceleration of 1.56 meters per second squared. All right, so that's all I've got for you in this video. Remember, confusion is the sweat of learning.